interference of light. Please write down next heading, interference of light. First, we'll write down the definition. What is interference, and what is the principle of superposition, and all. We'll write everything. So, whenever light waves from two coherent sources, whenever light rays from two coherent sources superpose at a given point in medium, then the resultant intensity at that point is different from the sum of the two intensities of individual waves. Bharashat, of individual waves. This modification in the intensity of light, this modification in the intensity of light at the point of superposition. Again, I told you, superposition is basically the technical name given to what? Overlapping, right? So if one wave is there and another wave is there, both overlap at one particular point. Matlab, there is one point on which wave one is falling, and on the same point wave two is also falling. So at that particular point, the resultant intensity will not be just the simple addition of both the intensities. No, it will modify. How it will modify, we'll see after a little bit. So the resultant in this modification in the intensity will at the point of superposition of the coherent waves is called as interference phenomena. Is called as the phenomena of interference. Is it clear? Is it clear, guys?
Yes, sir.
ठीक है. There are two types of interference generally which you people study. First is constructive interference. Constructive interference is basically at some points, the intensity of the resultant wave is maximum. Those points are said to be, we say when we say at these points constructive interference happened. Yes or no? And similarly, don't worry, Abhi, I'm just defining these things for you. I'm not done anything mathematical as of now. And there are some points, where Is it clear, guys? What is constructive interference and destructive interference? Some points पे intensity of resultant wave will become max. That point will be basically called as what? The points where constructive interference happens. And there will be some points where the intensity of resultant wave will become minimum. Here it is becoming maximum. Here it is becoming minimum. Then we'll say कि at these points what happened? Destructive interference happened. Right? Is it clear? Guys, is it clear? Hello?
Yes, sir.
Yes, sir.
What are the important conditions for interference? We'll see what exactly do you mean by coherent sources, है ना? Don't worry. So conditions for interference. First condition is sources must be coherent. Okay. The sources must be coherent. If the sources are coherent, then what do you mean by coherent? That is, they should have same frequency. This is the first condition. And please remember, it's not or, it's and. Both the conditions should be fulfilled, then only the sources will be coherent. Right? Sources must be coherent, that is, they should have the same frequency and a constant phase difference. What do you mean by constant phase difference? The phase difference between the two waves should not change with respect to time. Okay, is this clear, guys? Phase difference between two waves shall not change with time. This is what is meant by the sources are coherent. Is this clear? Both the conditions you need to mention. Generally this question is asked for 1 mark. What do you mean by coherent sources? So basically 2 or more sources are said to be coherent when they have the same frequency and a constant phase difference. Is it clear? So basically this is our first condition of interference. What is the second condition? Both the wavelength should be monochromatic, or listen, both the waves should be monochromatic, that is, in a particular medium both should have the same wavelength. Acha, by the way, if the medium is same, the wavelength is also same, can I say the frequency is also same? Right? Although we already did same frequency, but still, since we talk about same frequency, then this can be taken as a sub point, right? Is it clear?
Yes, sir.
ठीक है. So basically these are your coherent sources. I think everyone is pretty much clear about coherent sources, right? Please remember, if
Yep.
frequency is same, that implies omega will be same for both waves. Do you remember omega, angular frequency? So ये इस पे चीजें आएंगी, है ना? Don't worry, the things will come over here. Anyways, next heading, principle of superposition. Although this superposition principle has already discussed in 11th grade, but still we'll try to do it again. Principle of superposition of waves. Any two waves, not necessarily coherent waves, any two waves. कैसे करते हैं? It says that if two or more waves superpose at a point or at a common point in a medium, then that medium particle will oscillate under the phase of under the phase if says that if two or more waves superpose at a point in a medium, then that medium particle will oscillate under the combined effect of all those waves, such that the resultant displacement of a particle from mean position, the resultant displacement of particle from mean position will be the sum of the displacement produced due to individual waves. इसका मतलब क्या हुआ कि suppose if there is this particle where let's say this is wave 1, let's say this is wave 2, and let's say this is wave number 3. So guys, can you see at this particular point what is happening? All the three waves are falling simultaneously at this particular point, right? Yes or no? If there was this wave 1 only, and wave 1 would have fallen at point P, and it would have created a displacement of y1, which is given by a sine of omega t, because do you remember whenever a wave falls over a point, that particles start executing SHM, right? We are talking about only one point in a medium, right? Hello, ये अपन ने बात करी थी in 11th grade. If
Yeah.
you still don't remember, then always remember this thing कि whenever a wave it falls over a point, then that point oscillates in simple harmonic motion. If that wave is a simple harmonic wave, then that point will do a simple harmonic motion about its axis, right? Right? Is it clear? It can be plus phi 1 as well.
Yes, sir.
And no one said कि this will have this will not have any phase difference. It may have a phase difference. Similarly, if point P falls over here, if wave 2 falls at point P, so y2 is basically a sine of a1 sine a2 sine of omega t plus theta 2, right? And so on and so on. So basically, what does the principle of superposition says? By the principle of superposition, the resultant displacement, the net displacement yr is basically equal to the sum of y1 plus y2 plus y3 and so on. This is your principle of superposition. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So
Yep.
let's analyze your interference phenomena. Okay. चलो, so हेडिंग डाल लो. आज बहुत लंबा चौड़ा एक डेरिवेशन होने वाला है. मैथमेटिकल एनालिसिस ऑफ interference of light. So basically,
Is
guys,
it the textbook that
hi, it's in the textbook.
Okay.
I already told you about this particular thing. For interference, the waves should be coherent, right?
Coherent.
Yes, sir.
That implies their omega should be same
Mm.
and phase difference should be constant, where phi is
Constant.
the phase difference, है ना? तो suppose करो, suppose I want only the the addition of only two waves. Suppose there is this wave 1 and there is this wave 2. Both are both are superposing at this particular point. So if I say y1, will it be, let's say the amplitude is a1 and let's say it is sine of omega t. Sir, can you see omega t? Omega I have kept like this. Wave 2, I will say, let's say has an amplitude a2 and it will be sine of omega t plus phi. So guys, can you see over here omega I have taken as same, and can you see there is this constant phi phase difference between them? It won't change with time. So basically what I need to do, if these two waves interfere at this particular point or superpose at this particular point, so if y1 and y2 waves, and I've और ऐसा नहीं लिखता हूँ यार, y1 y2 will get confused. If wave 1 and wave 2 superpose at p, then by principle of superposition, can I write the resultant will be basically y1 plus y2? Can I write this? Guys, can I write it? Hello? Can I write it? If I can write it, then can I add it also? y1 की जगह पे I'll place a1 sin omega t. y2 की जगह पे I'll write a2 sin of omega t plus phi. Can I do this? अरे बोलो यार, can I do this?
Yes,
If I
sir.
can तो yes, if I can't then no. Tell me the truth, है ना? मैथ्स कर रहा हूँ मैं और कुछ नहीं कर रहा हूँ. Now a1 sin omega t as it is, and can you see this is sine of a plus b? What is sine of a plus b?
Sin A cos B plus
So
cos A.
sine a cos b plus cos a sin b. Yes. Can I
Yes,
say
sir.
this? Can I rearrange it like this? Can you see sine omega t is common in this? So can I say a1 plus a2 cos phi into sine omega t plus a2 sin phi cos omega t. Can I say this? Can I
Yes,
write it
sir.
like this, the resultant? Can I substitute? Can I substitute something? I want to substitute this thing as r cos phi, r cos phi, nahi, r cos theta, let's say, and I'll substitute this as r sin theta. Sir, why do you want to do that? You'll get to know the reason very soon. So substitute basically what? a1 plus a2 cos phi as r cos theta and a2 sin phi as r sin theta. Where what is theta, what is r, we'll get to know soon. Okay. So can I write from here yr will be equals to r common in both of them. Can I say cos theta sin omega t plus sin theta cos omega t? Can I say this? And again guys, can you see this is sin a cos b cos a sin b, right? So can I
Yes.
write yr equals to r of sin of omega t plus theta? What is this? This is another equation of SHM only, right? Yes or no? So what is this? This is the
Yes, sir.
resultant equation for the SHM of particle where wave 1 and wave 2 superposed. Is it clear? Itna samajh mein aaya? So now,
Yes, sir.
if I compare it with a general equation, can you see what is R? R is basically what here? R is the resultant amplitude after superposition. आया ना? R is the resultant amplitude after superposition, and what is theta? This is basically the initial phase of the resultant wave. Can I say this particular thing? This is the initial phase of the resultant wave, or can I say this is the resultant amplitude of the resultant wave, right? Can I say this, guys? R और theta समझ में आया
Yeah.
क्या है? R and theta is basically what? Initial phase and the initial, the resultant amplitude of the resultant wave. Is it clear, guys? Is it clear?
Sure.
So from here we get what is R and we get what is theta. So by this trigonometric, special kind of trigonometric substitution, we solve this. So guys, here what we did, here we assumed that R cos theta is equals to, I'll explain you with the help of phasors as well, don't worry. So R cos theta is equals to A1 plus A2 cos phi. आया ना?
Yeah.
And R sin theta was basically what? A2 sin phi. क्या यही था? A2 sin phi is basically R sin theta. A1 plus A2 cos phi is R cos theta. Yes? This is our equation number 2. This is our equation number 1. Can I just square it and add it? So on squaring and adding, will this be equals to, can you see what will be the left hand side become, guys? What will the left hand side of this equation become? It will become R square cos
R
square theta,
square.
and this will become R square sin square theta. When I add
Yes,
the
sir.
left hand side, it will become R square, because cos square theta plus sin square theta will become 1. Yes? On the right hand side, I'll get a1 plus a2 cos square phi. So sorry, a1 plus a2 cos phi ka whole square, which will be, when I'll open it using this thing, a plus b whole square, it will look like this, plus twice of a1 a2 cos phi. When I square this, I'll get this, plus when I'll square this, I'll get a2 square sin square phi. So can you see, guys, this term and this term are again can be added with each other, right? So a2 square can be taken as common, cos square phi sin square phi will become 1 again, and from here the R is equal to under root of a1 square plus a2 square plus twice of a1 a2 cos phi. किसी को कुछ याद आ रहा है? Is this formula looking similar?
Yeah.
Sure.
Do you remember the vector addition?
Yeah.
Yeah. Yes, sir.
So please remember this formula. And similarly, if I can divide these two, divide 2 by 1, then can you see R and R will get cancelled out. R and R will get cancelled out. Sin theta upon cos theta will become tan theta. So tan theta will be equals to A2 sin phi upon A1 plus A2 cos phi. ये वाला formula भी same है.
Yes, sir.
So I can do it using phasors as well. And if I want to do it using phasors, using phasor algebra, if I'll do, or using phasor diagram, whatever you want to say. Will this be your a1? Do you remember y1 was equals to a1 sine of omega t? What is the initial phase of this thing? Initial phase is 0. So can you see this? It is lying along the x-axis. याद है आपको phasor algebra? And similarly, if I have a2, then will a2 be somewhat like this? Yes or no? Where y2 is basically a2 sine of omega t plus phi. So basically initial phase is phi. That implies this angle is basically what? Phi, right? Yes or no, guys?
Yeah.
So basically, can you see over here, guys? I can just produce this whole thing like this. Parallelogram law of vector addition किसी को याद है? This is basically your R, and this is basically your theta. Is this clear? Guys, किसी को कुछ समझ में आया क्या हुआ?
Yep.
So if I draw the phasors of a1 and a2, the a1 looks like this, a2 looks like this, and just like vector algebra, you can find out what is R and what is basically the angle theta. Is it clear? Any doubt in this part?
No.
है Please remember, note, sometimes it might happen, your y1 equation is given as a1 sine of omega t plus theta 1, and your y2 equation is given as a2 sine omega t plus theta 2. That implies this phasor is basically at an angle theta 1 and that phasor is at an angle theta 2. So here also I can calculate the phase difference is basically what? Theta 2 minus theta 1, right?
Yeah.
So basically here this phase difference कितना हो जाएगा? Theta 2 minus theta 1, and all the formulas will be same. Just use phi as theta 2 minus theta. Is this clear? कितना टाइम हो गया आपने पास? We still have 15 minutes, so we can complete the whole mathematical part. इतना लिख लो. इतना clear है guys? So basically what did we get? We got two different formulas, है ना? What are the two formulas which we have? The two formulas which we have is basically the formula for resultant amplitude and basically the initial phase of the resultant wave, right? Is it clear?
Yes, sir.
लिख लो guys इतना. Once you are done, tell me. हो गया?
1 second, sir. Yep.
Everyone done?
Yes, sir.
ठीक है. Now let's do the special cases, है ना? we know this particular thing that r is basically under root of a1 square plus a2 square plus twice of a1 a2 cos phi. है ना? We know this already. And tan theta is basically equals to what? a2 sin phi upon a1 plus a2 cos phi. ये अपने को पता है. If what is the special case? If a1 or a2 is basically equals to a, that implies basically what is happening? Superposition of two equal amplitude coherent waves. Superposition of two equal amplitude coherent waves. So if this happens, then what will happen? Guys, what will happen over here? If the superposition will take place, then what will happen? A1 और A2 equal होगा. यहाँ पे रख दो इस फॉर्मूले में. Shall I put those values? So R will be equals to under root of a square plus twice of a square into cos phi. Can I write it like this? Yes or no?
Yeah.
Can I say, sir, 2a square can be taken as common and 1 plus cos phi? Can I write it like this? And do you remember cos of 2 theta? What is cos of 2 theta, guys?
2 cos square theta.
1 minus 2 cos square theta. ऐसा लिखते हैं अपन.
So it's 1 minus 2 sine
It's
square.
2, yeah, 1
हाँ
minus
sorry
2
1
sin.
minus 2 sin square theta. तो और basically can I write it? Sorry मैं भूल गया था. My bad. I am sorry. 2 cos square theta minus 1, right? Can I just send this 1 over that side? So 1 plus cos 2 theta is basically 2 cos square theta. We know this by double angle formulas, right?
Yes, sir.
So
Yes.
what will be this 1 plus cos phi can be written? Can I write 1 plus cos phi as 2 cos square phi by 2? Can I write it like this? Half pi.
Yes, sir.
If I can write it like this, then can you see under root of 2, I can take 2 as common, a square. So a will be out and cos square phi by 2, so 2a cos phi by 2. So can you see, guys, the resultant value becomes like this. So if a1 and a2 are equal, then r is equals to basically this much. Clear?
Yeah.
And similarly, if we solve for beta, this theta, sorry. So from here, tan theta will be equals to, shall I do the whole derivation? It's fine. Shall I directly write the result?
You can write the result.
तो डायरेक्टली यहाँ पर रिजल्ट लिख देता हूँ. tan phi जो थीटा आता है, solving for tan theta, we get, कहाँ गया वो? Where did that thing go? We'll get theta is equals to phi by. Okay. So if the waves are of equal amplitude, then please remember this thing will happen. The resultant amplitude will be twice of a cos phi by 2, and this will be theta equals to phi by 2. Is it clear? Now
Yeah.
it came back,
Yes.
and ऊपर वाला गायब हो गया. क्या हो रहा है? Guys, what is happening? I don't understand. This thing is up. ये गायब हो गया. ये अब आ भी गया. I don't know what is happening, but जो भी हो रहा है, I'm not doing it. Maybe Bhoot is doing. ठीक है?
Yeah.
So ये दोनों results लिख लीजिए please. After that, do you remember when we talked about constructive and destructive interference? Guys, do you remember constructive and destructive interference?
Yeah.
So basically, what is constructive and what is destructive interference? Uh, I try to copy the diagram from net. Take a second. Destructive interference. Draw the diagram at later on. घर पे बनाना. If interference. Yes. I don't want equal amplitude ones. I want this one. Yes. Copy image. Paste. I don't know. The figure cannot be size. I don't know. I can't maximize than this. So. Yeah, I can. Huh. So I guess you can see two diagrams very pretty much clearly, right? Guys, can you see there is this blue wave and there is this red wave? Guys, are you able to see both the waves?
Yeah.
Now, can you see over here, this blue one is basically y1 equals to a1 sine omega t, and this is y1 equals to a1 sine omega t, and y2 is also equals to a2 sine omega t. Can you see this thing very clearly over here? ये डायग्राम मैंने तो बनाया नहीं है, नेट से निकाला है. So can you see over here? There is one thing very clear over here. Can you see the time? Guys, can you see, guys? Both start from 0. Both become maximum at the same time. Both again become 0 at the same time. Both become minimum also at the same time, and time instant, है ना? And both become 0 again at the same time instant. So can you see, guys, here in constructive interference, can I say both A1 or basically both waves are in phase or are in same phase with each other? Can I say this? Guys, can I say this? Both waves are in same phase with each other. Both are becoming maximum at the same time, 0 at the same time, minimum at the same time. सब कुछ एक ही time instant पे follow हो रहा है. तो can you see whenever constructive interference happens, the waves are in same phase. Yes. And similarly, guys, can you see over here? This is y1 equals to a1 sine omega t. And this is y2 equals to minus of a2 sine omega t. Sir, why did you apply a minus sign over here? Because this thing was starting from the negative direction, right? I can write this thing as a2 of sine omega t plus pi. Plus pi. Why did I say plus pi? Because can you see this thing will become in the third quadrant, and third quadrant sign is negative. Yes or no? So can I write this thing over here? Can you see there is a phase difference of pi or 3 pi or 4 pi and so on? So whenever two waves are there in such a way that both waves, hello guys, can you hear me?
Yeah.
Are you able to see my screen?
No, I can't see it.
No, sir.
So let me share it again. मेरा net connection चला गया था, I guess. So in the case of destructive interference, both are in opposite phase. Both the waves are in opposite phase. Can you see over here? Both are becoming 0 at the same time. But can you see when this is traveling in the positive direction, this is traveling in the negative direction? When wave 1 is becoming positive in positive maximum, wave 2 is becoming negative maximum. both are becoming zero at the same time, but can you see when one becomes positive, another becomes negative? So basically that is what is meant by opposite phase. Is it clear?
Yeah.
So यहाँ पे in the case of constructive interference the waves are in same phase. In the case of destructive interference the waves are in opposite phase. If the waves are in opposite phase, can you see over here when I superpose both of them, so at that medium particle where both the maximums are forming, can you see the amplitude is getting added up, amplitude gets added up and becomes added up, and the resultant amplitude becomes more. So can you see the resultant amplitude R becomes equals to A1 plus A2, and here R becomes A2 minus A1. Sir, why did A2 minus A1? Can you see from the diagram A2 is greater than A1? A2 is greater than A1. Since we are adding, it doesn't make any difference, but when we are subtracting, it makes a difference, right? So can you see the final wave is in the same phase as the bigger amplitude wave? अरे कभी दो व्यक्तियों की if two people fight with each other, then कौन जीतेगा? जिसमें ज्यादा पावर होगी ना, right? The one with the greater
sir.
power will win, obviously. So वैसे ही these two were traveling in the opposite direction, they superpose at a point. So किसकी चलेगी? Who will rule over who? The one with the bigger amplitude will rule over the one with the smaller amplitude. So the same thing happened. So we did over here. Is this clear, guys? Constructive interference and destructive interference. This table is not finished. This table will go on till a lot more time. Okay? So I just introduced what is constructive interference and destructive interference. In the next class, we'll do some more. Anna? Some more things regarding phase difference, part difference, everything like that. So we'll calculate those things and all. We'll try to see some formulas which are responsible for this thing, and in 2-3 classes we'll be done with normal interference, and then we'll start with Young's double slit experiment. In one class I'll be done with normal interference, and then I'll start with Young's double slit experiment, then do the whole thing, then diffraction, then do the whole thing, and then polarization, and then we'll finish this chapter. मतलब कम से कम 5 to 6 more lectures, and I'll be done with wave optics as well on school level or JEE mains level. ठीक है? Advanced level will do later on. I'm telling you, advanced level में इस पे बहुत अच्छे पे question होते हैं. In the case of wave optics, the questions for JEE advanced, they are literally awesome. Nice. So anyways, thank you very much guys. We'll see you again. कब है next class? When is the next class? Is the next class tomorrow?
Tomorrow.
चलो
Yes.
बढ़िया. So next class will be done with interference, constructive, destructive. We'll do some questions. We'll try to start the Young's double slit experiment. ठीक है?
Okay, sir.
चलो ठीक है. Okay guys, we'll see you again. Thank you.
Thank you, sir.